Hi everybody, welcome to this Variscite and Texas Instruments joint webinar. My name is Pierluigi Pastoro. I'm from the Variscite R&D. Together with us today we have Brian Berner, Manager for Processor and Hardware Ecosystem from Texas Instruments. Today we will talk about how to start a project with AM625 based system module, and I'll leave Brian start with the presentation.
Thank you, Pierre. Yeah, so I think you have the agenda up here. So we're going to talk about the AM625 processor first, and then you'll take over.
Yes, basically we will start with the feature and the advantages of the process family. Then we will talk about the advantage of the system module. We will have a Variscite overview for the platform and the technical stuff on both hardware and software side. Okay, Brian.
Great. So for anyone that is not familiar with TI embedded processors, we actually focus on all of the key markets here that you would think of: industrial, automotive, personal electronics, communications, enterprise. But the product families there's three product lines that combine to create processors. So our ARM-based MCUs or high-performance MCUs. That's Sitara MCU. Sitara MPU is what we'll be talking about today. And then on the high end, we have the Jacinto SoCs and the investment vectors. If we switch to the next slide here, we'll hone in on industrial as the key market, where typically we think of the industrial SOMs being used in factory automation, building automation, and particularly devices that are using HMI commonly get used in industrial. So Sitara MPU is the product line that we'll be focusing on today. And then the investment vectors, I think they do apply across all of the product lines. We don't have a vision accelerator in this device, the AM625 that we're talking about, but you can run our Edge AI SDK, so an extension of our processor SDK on these A53 cores. So those investment vectors still apply across the board, and we'll jump to the next slide here. So again, the investment areas at a product level, general purpose, which we'll be talking about today. So you have your Cortex-A cores, potentially some real-time control, either R5F or M4. And then you have some optional features like GPU, video encode, decode, and vision accelerators. But the core functionality still has a rich peripheral set like CAN, PCIe, I2C, industrial Ethernet, and then our display. So the 625 that we're talking about today has dual display and GPU. And it also has single, dual, and quad A53 cores and a little M4 that we'll talk about later today. And then the extension of that general purpose family is adding some more application-specific cores, so plus networking, plus DSP, or plus analytics. So when we go to the next slide, we'll focus in on the general purpose family of devices. And so as the introduction mentioned, I focus on the ecosystem of products, primarily the hardware ecosystem, but the hardware doesn't do anything without software. So the extension of our hardware ecosystem is some of the software features that can be coupled with it. So Qt, Altia, and Crank, and Flutter are all examples of user interface or graphics that you can add on top of the base SDK. So I think we'll talk in more detail about Qt and Flutter. And then we do have some application-specific software ecosystem partners, Pionix being the one that comes to mind, where we have an EV charging demo. These software stacks are specific to the EV charging PLC communication for achieving high-level charging like vehicle-to-grid and plug-and charge. And this app just happens to be created in Flutter. So it's a good example of a combination of the UI and the application-specific software. And then, of course, our base software delivery is Linux Yocto, and then the operating system being Android. So I think that covers kind of the introduction at a high level to processors and where we sit within processors. So we will be focusing on Satara MPU general purpose devices today, and that's the AM625 family. So if we go to the next slide, we'll just talk a little bit more about the base SDK and how it's unified across all of processors. So industrial HMI auto cluster are kind of two sides of the same coin, right? Where you have a high feature-rich display. So panel PC in a lot of cases is the industrial application that you think of there. So the system performance, full HD, right? A lot of the software features that we have included for our LVDS IP that's in this device that's utilized very effectively on the SOM. And then across that, we have this TSN capable. All of our devices are TSN capable, even if they're not targeted towards networking. So we have the dual Ethernet with a cut-through switch for TSN capability on the AM625. Obviously, the maximum amount of integration for a cost-optimized system. Safety and security are big across TI, but in the general purpose family, security is a key component. And so I don't think we'll get too much into detail on security today, but we do have field securable devices by default that Variscite will be offering. And then, of course, all of the ecosystem partnerships. One that comes to mind is QNX, right? A lot of very specific medical applications, even outside of automotive, will require running QNX as the operating system. So if we go to the next slide here. So the AM625 family, what are some of the differentiations that we have in the device that Variscite can take advantage of? Power efficiency, anyone that's used Linux processors is probably familiar with dynamic voltage frequency scaling. This device runs at a low voltage without needing any DVFS, as it's commonly called, and runs at a significantly low power, right? So you have your active power state, less than 2 watts, and then your low power states, trying to get into that 5 to 10 milliwatt range running off of a battery. The feature display, like I said, it's dual display, parallel RGB, and then the full HD from the LVDS serial interface. And then the Edge AI, like I said, again, when you have those 4-lane CSI, even on the A53 cores, you can take advantage of that. We have some software partners that make it more optimized to run analytics on the A53 cores. So Plumer AI comes to mind. We've shown a few demos with Plumer AI, so you can do object recognition, facial recognition on this class of device. And then, of course, the peripheral set, working our way clockwise around this slide, in the simplified power solution. And then, of course, the security. Again, we won't talk too much about the security, but the secure boot, accelerating HSM, so the security on chip, and then the crypto is also included, right? So there's a whole page, I think, on the data sheet of this device talking about all of the security features. Even on the first page of the data sheet, like half of it is about security features, right? Because it's just so critical for IoT applications today to have very robust security features. I think we'll go to the next slide again here, and we'll be wrapping up in a couple slides. I think, yeah, when we talk about TI's value add, obviously the IP adds value, but also the manufacturing capabilities, right? So across analog, we have very strong manufacturing capabilities. When you get into embedded processing, obviously we need to take advantage of some smaller process nodes, right? So the AM62 family is in 16 nanometer FinFET. Our investments across all of TI are focused on delivering the best IP, obviously, with the most reliable supply chain. And so standard lifetime is 10 to 20 years. I think Variscite has a very specific claim on longevity, but obviously we're making sure that we supply the TI components to Variscite reliably, right, to service their customer base. And so we have essentially a new process node for industrial embedded processing that telecom has previously shifted away from. That gives us some advantages here in terms of expanding our capacity. So I think we can go to the next slide and talk a little bit more about the device itself. So if anyone wants to use the screenshot feature here and study this later, you're more than welcome to. It's also a block diagram that's on the datasheet page, so we definitely don't need to spend too much time here. I think the M4F is something that we'll talk about, Pierre will talk about in more detail, the security acceleration and then the graphics. So everything in the upper right-hand corner of the screen, we'll get into a little bit of detail on, and then the PRU is something that is has always been a value proposition for TI, looking back to the AM62, the AM335 devices. That's kind of our hero device for embedded Linux. The PRU stands for Programmable Real-Time Unit. And so that is kind of what some people consider to be a flexible I/O, but it is a coprocessor that is focused on real-time I/O, and so commonly gets used for I2C, SPI, MIC ASP, which is our equivalent to the I2S protocol, and then on the networking devices, that is Gigabit Ethernet comes out of the PRU as well. So a lot of features get opened up by having those flexible I/Os. And then I think, yeah, the safety and security features here, again, I won't list them all in detail, but we will be launching this SOM with the high secure field securable devices. So that is something to look forward to in terms of fleet management and over-the-air updates. We can go to the next slide, which will just talk a little bit about anyone that's familiar with AM335 that had used one of Variscite's legacy SOMs. I think it may not have been this AM335 family exactly, but it's the same AM3 class of device that was kind of our first foray into the industrial broad market. So the feature enhancements, the GPU, so we use an Imagination Open GPU that's been upgraded. The display obviously been upgraded, dual display capability with full HD. So you can run those two displays separately through the parallel RGB and the LVDS without suffering on the performance. And then again, just the peripheral set being expanded to what is commonly used in the industry today. So CAN-FD is the one that pops out on the lower left-hand side of the screen, right? So having CAN-FD integrated, 3 channels of that, more I2C, more UART, right? Just things that people need to be in that peripheral set, not having expanders and transceivers all over the place. And so I think the next slide will be our last one, and it's 2 slides, right? So this whole family of devices is split up into 2 products, the AM623 and the 625. Variscite has very wisely chosen to focus on the 625. So we'll just jump to the next slide, which zeroes in on the 2 devices that Variscite is releasing. So the dual and quad core A53 with the 3D graphics, the GPU, primarily capable of operating up to 1.4 gigahertz. Obviously, you can enter some other operating points for lower frequency. Again, the voltage scaling isn't needed there, so it's kind of just optimizing your power consumption by reducing the operating point of the device. And then obviously all of our industrial grade devices are rated from -40 to 105C. I think the SOM itself has another temperature classification, but our commercial devices are 0 to 95C. So even that commercial temperature range is a little bit extended there from 85 to 95. I think that covers everything. So yeah, we'll switch over to Pierre's part of the discussion here, and really excited about this new launch of the VAR-SOM-AM62 for getting products into the market faster. Thank you, Pierre.
Thank you, Brian. And now let's talk about the advantages about using a system module. First of all, a brief introduction about Variscite. Variscite is in the market since 19 years, with more than 5,000 customers. We have an internal production facilities, so we control everything from the first component to the last board that we release. The same is for the R&D. It's fully internal, so we can support customer 24 hours a day because the R&D is spread along the world, from US, Europe, Israel, and we provide several certification, so we can be compliant with several regulatory requirements. And we rely also on external ecosystem partners for the complete solution for the, let's say, for example, for the application development. Even if we are mainly focused on the hardware and on the basic support of the hardware. So let's talk about the advantages now. First of all, let's consider that the VAR-SOM-AM62 will be part of a pin-to-pin compatible family that can allow the customer to move from a lower grade SOM to a much powerful SOM. And this almost effort-free, because we provide to the customers also a hardware solution that can be used commonly to all the SOMs. We allow the customer to fully customize the SOM, deciding the size of the RAM, the size of the MMC, the component to be mounted on it, and we provide basically production-ready hardware and software. Of course, customer can customize, can cut or add the features, but as soon as the customer receives the evaluation kit, can start developing the application just using what we provide free, basically downloadable from the website. We do provide free support to the customer through the customer portal. Our software is fully public and shared through GitHub. We have a open wiki that is reachable without any password or other. And we provide the CAD file, the XF file for the carrier board, so that the customer can start from the reference design of the carrier board and customize the carrier according to his needs. About the longevity, as already told by Brian, we ensure at least 15 years for both hardware and software. So we provide some kind of reliability for the customer that are planning something over a longer period. Why using a SOM? Let's say that the advantages of using a SOM is that you receive the brain of your product that is basically ready to use. So we take care of designing all the basic interfaces. On the SOM you will find already the SoC, the RAM, the internal storage like the MMC. And let's say that all the critical parts, for example, the RAM that may be problematic for a design that you may want to start from scratch, is already tested, already validated, all the routing is done. Because the current design is usually quite easy. So while Variscite focus on the SOM, the customer can simply focusing on the carrier board. Obviously, while designing the product, you need to consider some topics. First of all, which interface are required. You may want or not the display, you may want or not all the USB connector that we provide, and this is part of the carrier design. Also, the size limitation. Our carrier is designed and thought for testing, but we have customers that reduce the size of the board to something really, really small to fit whatever size you actually need. The power consumption. This SOM is based on a processor, the AM62, that is really cheap in terms of power consumption, but you can even squeeze it more by disabling, for example, the GPU if you don't use the display or some other parts within the SOM. Also, the memory footprint is a good point, because we do provide an evaluation kit with usually 2 GB of RAM, but it's not sure that you need so much memory. Most of the embedded application may require even half a gig. So we allow the customer to test and then customize even the memory footprint. Of course, the processing power that you need is a good topic. You may need to run an application that requires a heavy CPU load, maybe not. You can choose the dual core or the quad core according to your needs. About the operating system, you have a wide choice, because you can choose between the Yocto BSP, the Debian BSP. We provide Android. Everything is based on what TI provide, so we just extend it with the SOM specific support for this SOM. Real-time constraint. If you have any real-time operation that must be performed, you can rely on the internal Cortex-M that is within the silicon of the AM62. And also scalability, because the capability to have the same SOM and change several options within the SOM allows you to provide with the same interface different products. Now let's start looking at the Variscite platform, and let's present the SOM. This is how the SOM appears. We are talking about a quad-core Cortex-A53. The internal Cortex-M can reach 400 MHz, the PRU 333 MHz, dual LVDS display 1080p, the Imagination GPU with 8 gigaflops and 500 megapixels per second, dual gigabit Ethernet, USB 2.0, 3 CAN, native CAN, so it's part of the SoC, MPCSI interface, built-in pre-certified Wi-Fi modules. You can see the metal plate in the image. That can be configured, even in this case, a single band or dual band, up to 4 GB of RAM, and up to the extended range, I mean, minus 40 plus 85, with 15 years of longevity. If you look in the details, first of all, you can check the size. We are talking about 67 millimeters by 33, and we can see here the main parts. So the DDR, the SoC, the gigabit LAN, we use the analog device add-in, the PMIC. We have also the codec here, the Wi-Fi as I shown before, and the DMMC is in the rear, but you can see here. Basically, it's the one in the lower right corner. Okay, the more technical session, talking about the hardware overview. Go through the SOM configuration, the scalability and compatibility, and we will talk about the carrier design, and specifically we will talk about the Symphony-Board. That is the board that will be provided with the evaluation kit. We will briefly talk about the schematics, the layout guideline, and we provide some useful links. Let's start with the SOM configuration. Here is what you are supposed to provide when you start your production and you need to order a specific SOM. So you you can customize almost everything. In this part, you can see, in this table, you can see basically three parts. The first three lines are those that are mandatory present. So you need to choose how many core you want. The CPU speed actually is fixed, but you can choose how much RAM you want. Then we start with the optional parts. You can have or not the MMC, and you can choose how many, which is the size of your MMC. You can have or not the audio codec, the gigabit PHY, the resistive touch panel. You can have the single band, dual band, or dual band Wi-Fi. You can have additional extra buses that are specific for the SOM. So the octa-quad dual SPI, or an extra parallel bus, or an additional SDIO interface when you don't mount the Wi-Fi Bluetooth module. And there is an optional mount option to decide if you want the reference voltage for the RGMI to 3.3 or 1.8, but also you can decide about the grade. So if you want the extended grade or the industrial grade. Okay, now let's move to the some overview in terms of interfaces. Here you can find in blue basically the interfaces that are working, let's say, in compatibility mode with the other SOMs. This means that the Symphony board that will be provided with the SOM will allow you to test these interfaces. For the other interfaces, these are obviously available from the SOM, but they may require additional hardware or customized hardware to be exposed rather than used. Maybe because the same pins are used on the Symphony board in some other function. This is because of the Pinmuxing capability of the SoC, but let's try to understand what is the Pinmuxing. So basically, every path of the SOM of the SoC can be programmed to have a specific function. It's the same, but basically in the hardware there is a kind of a multiplexer that allow you to choose which is the right function for that pad. So for example, here we can say that when this must also match your ordering info. So for example, if you order a SOM with the Ethernet controller, so the PHY on board, parts of the pin may have different allocation. If you look at pin 3, in case of no Ethernet controller, you have the ball AD18, but if you use the SOM with the PHY on board, that specific pin 3 of the connector will expose the pin 12 of the AD18 chip. And this is just a reference example. If we check the chances of every pin, you will see that there are some alternate functions that allow you to have different options for the same pin. Almost all the pins provide a GPIO function, but you can also choose an additional option. This also means that the same function may be available from different pins. So for example, if you look at the table 41 that shows the UART2 signal, you can see that the same functionality is available from different ball of the SoC just through a customized Pinmuxing. Now let's move to the Symphony board. Basically, when you download the schematics, when I say download, it's everything public, everything free. You can find the reference in the website. There are references for the FTP server. We don't have any closed document. So when you download the schematics of the Symphony board, you will find a specific page reporting the pinout of the VAR-SOM-AM62 and the label that are shown within the Symphony board. So you can track, and you can also download the DSN file for checking all the signals that you need. Now let's go into details. For example, if you look at the connectors, you will see that for the Symphony board will expose the LVDS, two LVDS actually, and you will find them basically as connected to the SOM, to specific pins. And this is a kind of standard approach for us for all the other SOMs that we have. So the page itself will allow you to understand where the pins are connected, and we try to design the SOM to be compatible with all the available SOM that we have. Now let's talk about the design, because we do provide the Symphony board, but the customer may want to customize the carrier according his needs. So when you download the board documentation, you will also have all the files related to the board, including the design, the properties that and the constraints that have been used to generate the board files, and you can reuse everything. So you have a starting point that is really strong to quickly go through your own carrier board design and customize everything you need. Let's say that when designing, by the way, the board, you need to manage some specific points. First of all, the boot configuration pins. This SoC, this SoC is able to boot both from the MMC and the SD card. We manage through a switch on the board the boot device, but the customer may want to customize the carrier according to his needs, as I said, but in any case, you have to manage these boot configuration pins. Another critical part is the reset. The POR signal in the carrier must be coherent with this SOM expectation. So if you use the reference implementation on our carrier, you will have no problem. But if you need any custom implementation, feel free, as long as you respect what is detailed in the device, in the SOM datasheet. Pay attention to the power section. You always need to ensure that enough power supply is provided. So depending on the power supply proximity, be careful with the bulk capacitance and pay attention to the 3.3 voltage supply for the carrier rails. And always verify the voltage level compatibility. There are pins that may be provided in the 1.8 volts domain, other pins that may be provided with the 3.3 volts domain. This is detailed in the device in the datasheet. And if not differently declared, usually we refer to the 3.3 volt domain. But when some configuration may change this to 1.8, we write this in the SOM datasheet. Just be careful. About USB, pay attention to the VBUS and the ID signals. If you are configuring the USB just like host, you can ignore the ID signals, but if you want it to be an OTG, always manage the ID. Last point, take care of the ESD and the AMI protection device for sensitive interfaces. And now let's also talk about the layout guidelines. So verify the correct placement of the SOM for the mounting hole specifically, and when placing the SOM, check the constraints. The constraints are really important, and we do provide the constraints for the carrier within the carrier files, so you don't need to start from scratch. Everything is already done, but you need to respect those constraints. And also, as I said, be careful with the bulk capacitance. About the cap, we suggest using at least 6 layer, and we suggest working with a PCB manufacturer that can achieve this stack up being compliant with all other constraints that may be required specifically for the high-speed signals. For example, I'm referring to the SD cards that can reach up to 200 megahertz. And if there is any misalignment in the design, you may experience problem with some specific SD card that may be, let's say, more sensitive. Okay. And what else? Let's talk about the routing now. No, this is okay. And let's talk about mainly the useful links. So we do provide, as I said, everything for free. These are the links. The presentation will be available online. So this link will be available, are already available. And in case of needs, you can also register to our customer portal and ask a question, both for hardware and software side. As I said, one of the key points for us is the customer portal for the support. We do our best to support the customer within 24 hours, and usually we succeed. Now let's move to the software side. Okay, we will start talking about the wiki. We will talk about the BSP support, what will be available for the developers, and we will talk specifically about a few software guides about Docker, software update, and the Cortex M4. Our wiki, if you reach variwiki.com, you will see a page like this where we present all our SOM. You can identify that the VAR-SOM family has the same connector, but specifically you can find that there is the VAR-SOM-AM62, and shortly we will provide all the information. But basically, this that I'm going to show you is a kind of preview or what will be available. As I said, we will support Yocto, Android, Debian, reasonably Qt, and FreeRTOS for the Cortex-M. Let's talk about the BSP. Currently, we are working on TI processor SDK version 8.5, and we tested this BSP against Ubuntu 18.04, 20.04, and 22.04. For the current BSP, we will rely on the pre-built toolchain from Arm, based on GCC 9.2. The U-boot will be the 2021-01. The Linux kernel is the LTS 510. Yocto is the downfall LTS. About the graphics framework, we support Qt 514 as it comes from the community. Variscite will add the WX widgets 3.2 and LVGL. Android side, we will support Android 12 on top, obviously, on what already provided by TI, because our work starts from what TI provides. The plan for the summer is to extend the BSP support to Kingston. Kingston will be based on Linux 6.1 LTS. The U-boot should be 2023-01. The GCC will be incremented to version 10.3. Graphics side, we will move to 5.15, and Wix widgets and LVGL will be basically the same. Version 3.2 Wix widgets is the latest table. And about LVGL, we are investigating because the maintainer is probably going to release version 9, while currently is only available version 8.3. We expect also to migrate to Android 13. And let's now talk about how the wiki will appear. So once you select the Yocto page, basically you should find a presentation with 3 columns, a general, build, and how to. The general section basically provides the basic information about how to start, how to use the recovery SD card. This is very important. Every single SDK that we provide came out with a recovery SD. Recovery SD is a kind of recovery image that you can download and burn on your SD card. and usually we provide mixed SD card booting with Yocto, but that allow to install both Yocto and Android. For Debian, we will provide dedicated recovery SD card, and we plan to provide also Cortex-M binaries already included in the Yocto distribution. Always in the general side, we have also some presentation about information about how to compile a simply hello world, building the same hello world but for Qt, and we provide the information about how to customize the IDE environments. We mainly focus on Eclipse. For historical side, it was the very first. Then recently we added the Visual Code block, Visual Studio Code, because it's one of the most used nowadays. And we introduced code blocks because of its feature related to the Wix widgets capability. So it has specific plugins that allow to design graphical application. Let's move to the build column. You will find the release notes. The release notes will show you every single detail of the recovery SD card that is available from the website. So which is the commit ID, which is the branch for both the U-boot, the kernel, the layers that we are using. You will have specific instruction to build step by step the BSP, and you will have also specific instruction to customize the U-boot code either from in the kernel, either from the source code or within the Yocto. But you will also have additional information, for example, to use software-per-date and Docker. The last column, the one on the right, is the how-to. Basically, every SD card comes fully tested. We have some quality gates, as I said before, releasing an SD card. And we need to ensure that all the how-to section are satisfied and everything works out of the box for the customer. So the customer does not need to install anything in Yocto. It's just usable for testing whatever he wants. Okay, and this is an overview of the wiki. Let me spend a few words about the customer portal. Basically, this is how it appears. The customer portal has been, we decided to use a customer portal and not the public forum to protect customer privacy, because sometimes happen that it's not easy for a customer to talk about his problem without releasing sensitive information about the project. That's why we moved from the forum. We used to have a forum a long time ago to this framework, because the customer is somehow protected. When you register with, when a customer can register multiple users to the same company, so the company can share the knowledge to all the employee without anyone else having access to this information. And basically, the customers can ask a question, even detailed question. We do provide specific services, including the hardware review. So if you design your own board, you can submit your design review, and we will do it. We will require some time for sure, depending on the complexity of your board. But we do provide at least feedback about your design based on our experience. Okay, let's go back to the hardware now, to the software now, and let's talk about something more related to the software layers. I'm talking about Docker. Docker is a framework that has been designed to allow virtualization, but differently from something like, I don't know, VirtualBox or other. It relies on the device file system. So Docker creates virtualization, but relying on the kernel that is running on the machine. This makes it much more lighter than a full virtualization of the system. And you can design and use your container elsewhere and then just migrate the container in your product and use it out of the box. All our SOMs are Docker ready because Docker basically requires a set of kernel configuration that must be enabled, and we ensure that all the kernel that we provide are those specific kernel feature enabled. We do support Docker for both Yocto and Debian. So just as an example, in Yocto, you need to build a specific image that had the Docker support. And while instead in Debian, you just need to download from Debian repository the Docker packages. But once done, the approach is the same. You run the Docker command and you can, for example, have your own Ubuntu distribution. In this case, in this example, we are talking about the Ubuntu 2004 on your Yocto system or on your Debian system. It's a virtualization for sure, but you are allowed to run a set of, let's say, standard features. And this closes the Docker part. Let's move to the, sorry. About Docker, we do provide the dedicated wiki page, and here you can find some additional documentation about Docker. Now let's move from Docker to software update. A software update is another very important framework that allows the customer to manage the upgrade of the system. Software update has been designed by one of the developers of DANX, the U-boot maintainer, and has been designed to be reliable and avoid any problem in case of power loss during the updates. Allows a rollback. So if for any reason you made an update and you don't like it, you can go back easily. You can authenticate your packages before doing an update. It's flexible because you can fully customize. We provide a sample implementation that creates a double file system, but you can customize this framework up to change or update just a single file. It's very, very scalable. Allow to have local updates through USB, HTTP, web server in general, but also order the air from remote and just using some protocol for the download of the package. Let's see how software update work, or at least our implementation. It is one of the possible implementation. The product may start from the factory with two root file systems. One is active, the other one is, let's say, sleeping. Okay? And at some point, you decide to have an update. So you start the framework, you get the update, you download the update, and you install the update. But you don't install in the active partition, you install it in the inactive partition. So in the inactive partition, you have now the version 2 of your file system. Once everything is fully completed and successfully updated, only at this point, the system update U-boot information to let him know that the next reboot must use the different partition. As you can see, there is a specific user data that is not changed at all. So whatever the application needs must be stored in the user data and will be available. Was available in the version 1 and will be available in the same way for version 2. And then you can continue. I mean, you can update to version 3, like roll back to version 1, according to your needs. This is the powerful of this framework that can allow you to manage almost everything. Okay, and now last point that we want to talk about is the Cortex-M that is within the SoC. Cortex-M allow real-time processing with low latency and deterministic operation. As you may know, Linux, although very efficient nowadays, cannot be certified to be a real-time operating system. So whenever there are strictly there is a strict requirement about real-time operations, the Cortex-M may help, for example, for motor control, safety application, rather than control the triac or whatever. TI provide Code Composer Studio, that is an IDE, quite famous actually. So this come in help whenever you need to design your own application for Cortex-M. And just as reference, you will find a Hello World application ready to use from the TI code. Okay, now the presentation is concluded, and let's start with the questions. Okay. Are you supporting even go to package? I suppose the customer is asking about the software packages. So basically, everything will be available as open source. The BSP will be fully open source. The recipes will be based on most of the recipes will be based on the Yocto project. On top of it, there will be the meta TI layer. And on top of it, the meta Arago layer that provides some BSP simplification. And the final part of the stack is the meta Variscite. We provide two specific layers, one for the BSP part that is dealing about the very basic part. I mean, your boot kernel and all the relevant part with.
Yeah, Pierre, I think the person who asked that question may have left. So
Okay.
I didn't get any additional context on it. I know the cost for the board that was answered, but maybe just an overview, a quick overview of kind of the configuration options again might be helpful.
You want me to show again the configuration options?
Yeah, just the impact on cost for selecting, say, DDR size.
Honestly, I don't have this detail now, but
Yes.
our say will be available for every question about costs. This is
So the answer regarding cost is contact sales@variscite.com. But yeah, the starting at $33 is listed on Variscite's website. But obviously the configuration will impact cost. Some more interesting software-related questions are coming in now. I don't know if you want to read those out loud here, Pierre.
Okay. Since someone asked about the availability of the video, yes, this video and all the presentation will be available on the Variscite website. And what else?
Does AM62 support ISP for Bayer to YUV conversion. So the AM62 device itself does not have an ISP. So out of box, if you're working with a camera, you would have to have either an on-chip ISP like the OV5640 or a on-module ISP. You can do software ISP, but you're really going to have to downscale your resolution.
Okay. And there's a last question about, can customer go to production with Debian powered, with Debian provided? We have customers that go in production with Debian. Let's say that nowadays, due to the powerful of these SOMs, we are talking about an SoC that can provide 4 Cortex-A53 at 1.4 gigahertz. It's quite easy going production with Debian. Let's say that some years ago, when there was a single core and there was not such a high speed, it was a bit hard. Let's say that Debian has been designed for a PC. It's kind of a different target. But nowadays, Debian runs quite smoothly on these platforms. Okay.
I think there was one in the middle about automotive applications. You skipped there, Pierre.
For automotive application, do you support functional safety AC level S? I'm not sure about this. I mean, this is something that is not part of the Yocto support. So may be provided from third party, but it's not part of the Yocto packages.
Yeah, so the device itself is listed on TI's website, the AM625, as functional safety compliant. If you go to TI.com, it lists the definition of all the functional safety features. So there's functional safety capable, functional safety compliant, but at the end of the day, it's a system level test. So you can read through that. I think to some extent, automotive typically uses a larger package, larger pitch. The full temperature range is only qualified on that device. So this SOM as is might not be automotive capable, but you could still look into functional safety use cases.
Let me see additional answers, so I think we can move on. For your reference, here we provide the website link, the sales email, the link to the Variscite portal, to the wiki, and to our GitHub. So thank you, Brian. Thank you all for joining today, and see you to the next webinar.
Thank you, Pierre.
Bye-bye.